Hello everyone, welcome to Maths IEC. Here's a typical A-level physics exam style question on Newton's laws of motion. Please pause the video and give it a try. When you're ready for the answer, press play. Three blocks A, B and C of masses 2, 3 and 5 kilograms respectively are connected by light inextensible strings on a smooth horizontal surface. The horizontal force of 50 newtons here is applied to block C, pulling the whole system to the right. Part A, calculate the acceleration of the system. Now, this question is actually very straightforward. So all we need to do is we can write F equals ma to the whole systems. Now I'm going to separate the whole system with this color. So you can see this is the whole system. Now I don't need to worry about T1 or T2 because they become what we call internal forces. So all we need to do is for the whole system, I'm going to write F is equal to ma to the right. Now the force is 50. Mass is 5 add 3, 8 add 2 is 10. A, obviously, A is equal to 5 meters per second squared. So I know the whole system is now accelerating at 5 meters per second squared. Here. Part B. Calculate the tension in the string between blocks A and B. Oh, this T2. Now, to do this, I need to consider this object only. So I'm using different colors to show this. So here's the system. Now, for mass A, I'm going to write F equals ma again to the right. Now, if I consider this one, I can see the whole system is inside. The only force acting on that particular mass is T2. So the force is T2, mass is 2, acceleration of the whole system is 5. So that will be 10 newtons. Calculate the tension in the string between blocks B and C or T1. Now, I have two options to do this. I can either consider mass B and do it, or I can consider mass C and do it. So let's do for mass B. Now, here's my system now. Right. Now look at this system. The mass is 3 kilograms and there are two forces acting on it. One is to the right, T1, the other one here to T2. Since there are two forces, let me just quickly draw the system. So we have this 3 kilogram mass and to the right we have tension T1, to the left tension T2. Under these conditions, it's accelerating to the right at 5 meters per second squared. So obviously, I can write F is equal to ma to the right. Now, T1 is to the right, so that's positive. T2 is in the other direction, so I have to take away, it's negative. Is equal to mass is 3, A is 5. Now, from the second part, we already know that T2 is 10 here. Oh, so I can substitute T1 take away 10 is equal to 15. Move it to the other side. So we know the tension 1 here is 25 newtons. That's the answer for part C. Now, that's all you need to do here. But I mentioned earlier that you can actually use mass C and do the same. So let me show you how it is done. Now, let's consider mass C here. Like that. See, I'm separating the object. Now, if I think about mass C, which is 5 kilograms, there's a force of 50 newtons to the right, and there's a force of T1 to the left, and it's accelerating to the right at 5 meters per second squared. Obviously, 50 is bigger, so I'm going to write F equals ma to the right. So, 50 take away T1 is equal to m is 5 A is also 5. So I can say 50 take away T1 is 25. Move to the other side. 50 take away 25. Again, I get exactly T1 is 25 newtons. Same as this. It's exactly the same answer using any one of the masses. So it's really important to keep in mind in questions like this, and whenever you write Newton's laws of motion, Newton's second law, this kind of F equals ma, you need to very clearly define your system. Now, I wrote it first in purple. I wrote it for the whole system. Then in dark green, I did it only for mass A. In red, I did it only for mass B. In light green, I did it only for mass C. I can also do it for masses A and B if I need to do that. There are multiple ways of doing it, as long as you very clearly identify your system and you clearly get all the forces, and then you can write it.